Morning, girls. We've done binomial theorem last lesson. Let's have a look at a few HSC questions. Let's have a look at question 3 to start off with. Alright, so it says let Px equals to, I've written up on a board, that series over there. What is the coefficient of x to the power of 8 in the expansion of P bracket x plus 1? Okay, so in order to do this question, that's a question, so we need to obviously substitute this into this series. So what this means is 1 stays the same, but instead of x, it becomes x plus 1, plus instead of x squared, we have this, that. So the question is, from this series, what are the numbers that has x to the power of 8 in front of this series? Well, let's just have a look at it one at a time, right? Obviously, it can't be anything from here because the most you're going to get is x to the power of 3 because the highest power is 3 in that bracket, right? So what we want to explore is a couple of terms before x to the power of 12. I know the first power of x to the power of 8 is going to be in this bracket, right? And then obviously that's also going to exist in this bracket. This bracket, I'm just going to keep writing to a 12, okay? Alright, so from here, the question is to find the number that comes in front of x to the power of 8. So from here, girls, where will I get to the power of x to the power of 8 here? Wouldn't it be the very first term? Because the very first term is 8c0, and because the first term is x, and it starts with the highest power, yeah? So that's going to be x to the power of 8 coefficient from this bracket. How about from this bracket? Plus, because it says plus. This one's going to be from the second term, because if you get the second term, which is 9c1, you're going to have x to the power of 8, yeah? Because the term before this is going to be 9c0 x to the power of 9. So it's got to be that term next. From this term, it's going to be then the third term, which is 10c2 x to the power of 8, because the first term is going to be the first term is going to have x to the power of 10, 9, and then 8. Similarly for that one, it's going to be 11c3 x to the power of 8. So that'll be the fourth term. We'll have the 12c4 x to the power of 8. Okay, so that's basically it. What you need to do now is put all of these numbers in the calculator. So I guess I just did this question for you instead of as a guide. Let's have a look at question 9. Similar question. Sorry girls, I wrote the question wrong in my previous board and I did a slight mistake in my working out. So let's do this question again. Alright, so like I said, alright, with this question, we want to look at the coefficients. So we want to start by using the rule NCR AN minus RBR. Okay, obviously in this case, this is 20CR. Now, for A, you don't want to substitute the first term as A, you want to substitute the second term as A. So you think of this question as 2 plus 5x to the power of 20, because like if I substitute it like that, so my first term is 2 to the power of n minus r is 20 minus r. My second term is 5x, so bracket 5x to the power of my r. Okay, if I do this, this is what I want. If I expand this out, I get x to the power of r, which is what I'm given. But if I substitute it the other way in this order, I'm going to get instead 20cr bracket 5x 20 minus r and 2 to the power of r. See, if I don't want that, because here I get x to the power of 20 minus r, but I need x to the power of r, okay? So I don't want this, okay? So this is the technique. If you want x to the power of something, you can swap the order of the bracket around, sorry, the terms inside the bracket, and then use the formula like that. The answer won't change, okay? Right, so if I do this, let's have a look. I get 20cr, 2 to the power of 20 minus r, times 5 to the power of r, x to the power of r, okay? I'm going to leave it like that because there's not much else I could do from here. And they're saying the coefficient of this, so the number in front of xi, is the same thing as the number in front of x to the power of r plus 1. So let's do the same thing for this now. So in this case, I'm going to have 20cr plus 1, 2 to the power of 20, take away r plus 1, 5x to the power of r plus 1. So this is 20cr plus 1. 2 to the power of 20 take away 1 is 19 minus r. And then I get 5 to the power of r plus 1, x to the power of r plus 1. Okay, so now we need to compare the coefficients of these two, because that's what the question says. The coefficient of x sine x to the power of r plus 1 are equal, so find r using these two. Alright, so what you need to do is write the full combination definition out if you forgot. Okay, that. So let's use that there. Alright, so 20 factorial, 20 minus r factorial times that, 2 20 minus r times 5r, okay? You don't write the x up because we're just equating the coefficients only, okay? So don't write the x bit. That's the mistake I made in my previous video. 20 factorial, 20 take away bracket r plus 1 bracket factorial, r plus 1 factorial times 2 to the power of 19 minus r times 5 to the power of r plus 1. Alright, so we got to equate this and find r. Looks really disgusting. So what to do? Okay, so let's compare the denominators one at a time again. So this is 20 minus r minus 1 factorial. So which of these two are bigger? Obviously this one, because that's got 20 minus r factorial. So what this means, 20 minus r factorial means 20 minus r, 20 minus r minus 1, so on, all the way down to 1. So what this fraction needs is to be multiplied by that on the top and bottom. Alright, so let me just get rid of this. Times the top by 20 minus r, 20 minus r. Let's have a look at these two denominators though. Which one's bigger, r factorial or r plus 1? Obviously r plus 1, so on this side of the fraction I need to times the top and bottom by r plus 1. R plus 1, r plus 1. Okay, so if I do all that, okay, on the left hand side I get 20 factorial r plus 1 over these two combined. I'll write the 20 minus r factorial first, is now r plus 1 factorial put together, times 2 to the power of 20 minus r times 5r is equal to, this is equal to, I'll write it in blue, hopefully I can fit it here, 20 minus r over, same denominator now, okay, and then write that, 2, 19 minus r times 5 r plus 1. Okay, let's see what we can do here. Denominators are the same, so I can just get rid of them. Like, we're just comparing the top now because they're the same. Now, here's what I can do with this and this. See how they're almost the same? So I want to divide both sides by the smaller one of these. Which one's the smaller one? If I divided both sides by 2, 19 minus r, okay, what else can I divide by? Which one's bigger on this side, 5r or 5r to the power of r plus 1? Obviously, that one's smaller, so you want to divide by that. So let's divide both sides by, what I'm doing here, is you're dividing both sides by the smaller power from each. So from between these two, that one's smaller, so divide both sides by that. Between that and that, this one's smaller, so divide both of them by that. So we can simplify it as much as we can. So let's see what we get. So let me just write this out. That's gone. That just leaves the power of 1, yeah? Because if you're dividing with the powers, you subtract them. With this one, that's just gone. That just leaves 2. 20 factorial, 20 minus r. Those two are gone, but here it leaves me with just 5 to the power of 1. So just 5. Okay, we're getting somewhere. What else can we cancel from here? Looking at this, they both have 20 factorial, so get rid of that. So now I can finally have some sort of decent expression. What a piece of work, eh? This better be right. Wow, a long piece of work. Yeah, girls, that's how you do this question. So let's move on. If you have any questions, let me know. All right, so it says, by using the fact that is equal to that, show that 11C5. So I wrote down all those symbols in terms of that. Show that is equal to all that. Yeah, it looks awfully tricky, but it's not too bad. Okay, let me try and break it down. So what you need to be able to spot out from this question is this term comes from that bracket. Can you see that? Because this is to the power of 11. It's got 11 here. Now, it says C5, okay? So what I'm noticing, if you need to notice these patterns. You've got 5 there. Now, from here, obviously this one comes from this because it's got to the power of 8. And once again, this has 5 as well, okay? So we want to do something with the 5. This one obviously comes from this bracket because it's got to the power of 3. Now it's multiplied by a term from here because it's got 8. Now also noticing 1 and 4. If you do like, yeah, so 1 plus 4 equals 5. So there's something to do with 5. And yeah, if you keep going, this is from 3, multiply that, and the last one is just from here. Okay, so I want to figure out from this bracket what the full term that comes with that coefficient, all right? So if it's 11C5 from here, what other numbers are there? So what I'm trying to say is, you know how if you, I want to know what these two values are, okay? So what is it? The first one is just 1, so it doesn't really matter, times b to the power of r in this case is x to the power of, that's my r, 5. Okay, so what I need to do is I need to work with x to the power of 5, all right? So what that is, let me just write it out, x to the power of 5, okay? Now then, surely, 8c5 from there, okay, if I apply the same thing, see how my second term is, the second terms are all x's, so this is going to be x to the power of 5 here, yeah? Because it's 5 there as well. Plus, so this is what, let me show you what I'm doing. What question wants. This is what question wants us to prove. Okay, so we're not necessarily answering the question, we're just trying to figure out what the question wants. Okay, so 3C1, what does that mean? What's the term for 3C1? That's the second term. So the second term is just, yeah, it's just going to be x. The second term is always going to have the power of that number, okay? Times by 8C4 means x to the power of 4. So as we can see here, these two multiplied becomes x to the power of 5. So we're clearly focusing on the coefficients with x to the power of 5. That's the first thing you've got to be able to figure out. Okay, let's just keep going. 3C2 x to the power of 2 times 8C3 x to the power of 3. The last one is just this though. It's not x to the power of 5. It's x to the power of 2. Okay, so that's what the question wants us to prove. To prove this, specifically, let's have a look at that. So let's just write them out. So 3C0 plus, if I'm just expanding this out using binomial theorem. Okay, let's do the same thing for the second one. Unfortunately, that's the power of 8, so we got quite a bit to do. Okay, so I'm just going to keep writing them out. Okay, here's a technique. Let's start off with that one. What do I need to multiply that with from here to get x to the power of 5? Because remember, x to the power of 5 is our main focus, all right? This is going to get me x to the power of 5, isn't it? Yeah, because this is just a 1. 1 times x to the power of 5. So that's my first combination. So let's write them down. So, pairs power of 5. Okay, that's what I'm trying to do. Top times what bottom do I need to give x to the power of 5? So my first one is 3C0 times 8C5. I'm just going to write the coefficients, not including the x to the power of 5. Yeah? Let's keep going. What do I need to multiply that by with here to get x to the power of 5? Well, I've got x to the power of 1 here. I need x to the power of 4 then. Yeah? Because 1 plus 4 is 5. So that means 3C1 times 8C4 will give me the next coefficient of x to the power of 5. And then you keep going. Okay? So that's the technique. So what do I need from x to the power of 2? I need x to the power of 3, so that one. And let's keep going. Last one. 3c3 x cubed. That means I need x squared times. Okay, so we're getting somewhere. So have a look at this and see if I'm close to what they want. Can you see the answer forming? Okay, so can we see 8c2s here? But see how that's alone? 3c3, if you put all of these in the calculator, okay, instead of the 8c2, 3c3 is actually just 1. So I've already got the last term. Have I got this? 8c3, 3c2? Yes, I do. I have that ticked. But this one, 3c1, 8c4? Yes, I do. 8c5? Yeah, see this one? If you put 3c0, that's also 1. So girls, that's actually the question done. That's how you do it. So what you say is by comparing hand side. Okay? So this is how you do the question, girls. By comparing the coefficients. Alright, good luck looking through this and just try and absorb it and understand what you can.